Okay, so you're going to need your periodic table and your notebook, a pencil to write with. And then you're also going to need your green sheet. I'm going to be giving out your green sheet right now, so if you're watching this on the video, you already have the green sheet. Just hang on to your green sheet. Anything that I give you that's printed on colored paper, you should keep. You are always able to use the colored papers on tests. And if you're taking AP Chem, don't get rid of any. Because it will very much help you to have all these materials. All right, so on the light green sheet, we will be getting a dark green sheet in a little bit. But on the light green sheet, you will see that there's this complicated flow chart here on the right-hand side, and then there are instructions on the left. I'm going to take you through all of these different types of compounds. Today we are only going to get through compounds types 1, 2, and 3. We'll do 4 and 5 on Thursday. All right, so what is this nonsense? This is all so that we can learn compound nomenclature. This is a really important concept. You're going to need to be able to know how to do this from now, until the end of times. So paying attention today is a good idea. What is this? Nomenclature is a systemized way of naming things. Do any of you guys have family traditions for how people get named? Does anybody have Cameron?
But that's not
No, but that's kind of a tradition. Where you have similar middle names, or you get the middle name of your grandpa or somebody. Or does anybody have a junior in their family? Yeah. So those are already systematic ways of naming people. In Russia, they have this complicated thing where the middle name tells you who the name of what the name of your father was. It's really complicated. Actually, it's not really. But the reason we have to have a systematic way for naming compounds is that there are multiple different ways that elements can bond with each other. And so we have to be very clear with what we're describing by the name. And also, we need to have a way that all chemists using all different languages will understand. And so while these words are English, there is nothing, they would also be used, called these same names in other languages as well. Okay, so let's start with the beginning. I'm going to show you how to use this flowchart. The very first thing you need to do whenever you're naming any compound is to identify your first element. And so I'm going to give us an example. You probably already know the name of this. If you do, just hang on. I want to explain to you how the name is determined. And so the first thing we want to do is identify the element. Is it a nonmetal or a metal? That determines what you're going to do naming-wise. Okay, so do you remember on the periodic table which side of the staircase the metals are on? Metals are on the left side. That's true. So carbon is over on the right side of the staircase, so that must mean it is a non-metal. So that means that there's only one way to name compounds if that first item is a non-metal, and that's the rule set number 1. So now once you get to the big number here on the flowchart, go over to the left side of your paper, and I will explain to you how to do the steps for this naming. Okay, so the first step says to write the elements as they appear. So that means I've got C, which is element carbon. And what is oxygen? What is O is oxygen? My bad. That's step 1 of the naming rule. Or I guess on your periodic or your green sheet, that's really step A. Step B says to do something to the second element. It says the second element uses the IDE suffix. So that means that we have to change the name of oxygen from oxygen to oxide. So how do you know what the suffix is? That's a good question. The group 7A is pretty easy. Fluorine becomes fluoride. Chlorine is chloride. Bromine is bromide, etc. But then oxygen is oxide, like I mentioned. Sulfur is sulfide. Nitrogen is nitride. Phosphorus is phosphide. If you had carbon as the last element, if it was the second one, it would be carbide. And so you can kind of see that what the pattern is. Some of them are a little bit more confusing than others, like oxygen or sulfur, because you have to take off different things. But we just want to make sure that that's always an IDE suffix. This will be important for some of the other naming rules as well, so knowing this is essential. Okay, that's step B. Step C says to add appropriate prefixes to each word to indicate how many atoms of each element are present in the formula. Okay, well, now we need to know how to use a formula. So how many carbon atoms are appearing in this formula? Just 1. So that means that we would use the prefix for 1, and I give you the prefixes here in this little table. So 1 is mono, and it just becomes part of the word carbon now, so it's monocarbon. And then how many oxygens are there in this compound? 2. So what's the prefix for 2? Di. But do we call this compound monocarbon dioxide? No, we call it carbon dioxide, right? That's because step D of your instructions tell you if the first element has only 1 atom, omit the mono from this part of its name. So that means we're going to cancel out that mono, and we will write carbon dioxide. And that's how this friend got its name. Okay, that made sense to us and was easy because we already know how to name this thing. So let's talk about some different examples that maybe are a little bit more complicated. Yes, Jared?
I don't know if you can see this, but you put carbide.
You don't ever change the ending of the first element, only the second element. All right, so let's do some examples of this. If you think that you're understanding, I'm gonna put a whole list of compounds on the board. Try them on your own and I'll give you the answers. And if you think that you just need some more help with this, no problem, work at my speed. If you are not remembering the names of these elements and their symbols, using the periodic table is a good idea, but this is part of one of the reasons why I asked you to memorize them, because if you have to go up and look every single thing up, it's just going to take you an absolute age. And let's give you another one. All right, so like I said, if you feel like you're doing well, do all these on your own, and then come back and check to see if you got the answer right. Alright, I'm gonna go through each of the like instructions individually for each of these. Alright, so step A says to write the elements as they occur. Phosphorus. Phosphorus is not OUS at the end, it's just US. And then fluorine, but I know that I need to have that IDE suffix, so I'm going to already write it down as IDE. Does that make sense, why I did that? Alright, so then I did step B already. Step C says to use the prefix that corresponds to the number of that element. So how many P's are there? 1. So do we write mono in front of it? Well, we can, but we'll have to erase it. So I'm going to leave off the mono here. But how many fluorines are there? 3. So what's the prefix for 3? Tri. And that becomes one word. So my compound's name should be phosphorus trifluoride. Spelling does matter. Now, again, the reason I didn't write mono here is because we don't ever write mono if it's on the first element in the compound. We do write it if it's on the second element, though. So I'm just going to scribble it out. That's the proper name. All right, let's do the next one. Se is the element. Selenium, sometimes pronounced selenium. I'm pretty sure it's one L, yep. And then bromine is Br. I'm gonna a little more space here. But I'm going to write it down as bromide. Any questions so far? What should be the prefix for selenium? It should be mono, right? But we're gonna have to end up erasing it because we don't write that mono on the first element. What should be the prefix for bromine? Di. So then erasing that mono, my compound's formula should be selenium dibromide. Now, it happens the most that that first element has only one of it, and so oftentimes you're going to have that be just nothing because the mono gets dropped. All right, give HF a try. So I started with steps really A and B. I wrote the names down. I changed the suffix of fluorine. Now I need to figure out my prefixes. H should have a prefix of mono, but nothing. And what's the prefix for fluorine? It also is mono, but that one we do write.
Wait, why do we write that?
Because it's on the second element. Yep. Alright, now let's do the next one. Because it's going to get like even more complicated now. Okay, so steps A and B, nitrogen and oxygen, but I'm going to change it to oxide right away. Now, what should be the prefix for that nitrogen? It should be di. In this case, though, we don't erase it. We leave the di on. Why do we leave it on if it's di? We only take it off if it's mono. And frankly, I think that makes it more confusing, but I think that chemists, when they were devising this, were like, oh, we don't need to write mono because everyone will just assume we mean one. And then what's the prefix for the oxygen? Tetra. So really, you have always two words or like two names for a compound. The first name and then the last name. And they're two different words, like they're two separate words. Neither of them are proper nouns. So there's no reason to capitalize the first letters of those words. So a compound's name, while it has a first and a last name, it's not like a people, it doesn't get a capital letter. All right, try that last one on your own. Yes, honey. Remember, it's silicon, not silicone. There's no E at the end. It is wrong if you put the E there. That means something different. So hopefully you're starting with silicon oxide. And then what are your prefixes? Di for silicon, and what is it for oxygen? Hexa. So in these names, you're going to end up with getting a lot of like weird letters that are together. Normally we don't see like hexaoxide, like that's not a thing usually you see in the English language. That doesn't mean it's not possible here in these chemical names. All right, how do we feel about this? Thumbs up if you feel like it's easy, thumbs down if you hate this, thumbs medium if you're unsure. Okay, that's looking pretty good. All right, I think I am going to go on to the next type of compound, and we'll come back to this and check to see if you remember it in a half hour. So that was compound type 1. Let's talk about compound type 2. All right, back to our flow chart. Always our first task is to use the right side of the green sheet to determine which one of the rules we need. There are, again, 5 different sets of rules, and it's really specific. A compound can't be part of both of these sets of rules. So if you're a compound of type 2, you can't be a compound of any other type. Okay, so if your first element is in group 1A, so everyone hydrogen and down. Group 2A, so beryllium and down. Or if you're the random element aluminum, there are 2 different types of compound you could be. So as you can see here, if your first element is a metal, we know that it's a metal because it's on the left side of the staircase. And obviously group 1 and 2 are on the left side. Aluminum also is on the left side. Now, the next thing that we have to do is we have to decide how many total elements are in our compound. So in other words, if you count the number of capital letters, that will tell you which one of these 2 options to choose. If you only have 2 capital letters, you will choose compound type 2. If you have more than 2 capital letters, it's something else, and we'll talk about that in a minute. Okay, so let me give you some examples of this. If you think you know what you're doing, go ahead and work ahead and see if you can get it. Okay, so all of these compounds start with a metal, and they all start with somebody who is either in group 1A, 2A, or aluminum. They also all have only two capital letters. B and C, L and F, M and O, A and O. So that's why it's really important to not be writing nonsense like this, because that will not help you. Also, it's not good for them. Okay, so let's talk about that first friend. My rules say, actually I feel like these are pretty easy. It says to name the metal, and that's the first word of your name. So, what is Ba? Ba is barium. And then it says to name the nonmetal, which is the second element in your compound. And remember, we want to use the IDE suffix for everything. So chlorine now would become chloride. And that's literally it. Do we need to do anything with the fact that there's a 2 on this chlorine? Our rules don't tell us to, so we shouldn't. In ionic compounds, you won't use those prefixes that you used up here. How do I know that? Well, my instructions told me not to do anything about that. All right, let's do the next one. Li is the element lithium. And F is the element fluorine. Remember, it's FLU. And I know that I have to use the IDE suffix, so I just write it down right away. I'm a lazy person, so why do more work than I need to? Any prefixes? No, because our rules don't say anything about the prefixes. That's all you have to do. This is actually easier, I think, than what we just did. So then what would be the next compound? Yep. And its second name? That's it. What about the last one? Al is aluminum. I had a really sweet chemistry TA who was from the Middle East, I don't remember where. And he always pronounced it aluminum. The Brits pronounce it aluminium, which makes no sense because there's no extra letters. But they're weird about their pronunciations. You know, like Worcestershire is how you spell it. Oops. S-H-I-R-E. What do you pronounce it? Worcester? Them crazy Brits, they're weird. Any questions about this? Elliot? Yes. It is. It is. I'm glad you asked that. I was wondering if somebody would. So a while back I gave you this example as an example of a covalent compound. Hydrogen is one of those weird elements where it could be located in group 1, but it also could be located here above carbon or above fluorine. So the actual proper way to name this name is not hydrogen monofluoride like I showed you before. You could also name it hydrogen fluoride without the mono, but it also has another name. It's also hydrofluoric acid. So which of those 3 names is the proper name? Yes. They all are understood to be the same thing. So don't let that like boggle your mind. There are other compounds as well that have other ways to name them, but if you follow the instructions on the flow chart, you'll be okay. How are we feeling? Thumbs up, thumbs down, thumbs medium. Was that easier or harder? I think it's easier, but that's just me. Also, this is maybe not my first time looking at this, so it's hard for me to sometimes know if something will be hard for you. The next thing I'm doing is handing out what's called the pink sheet. This is another thing you can always use on tests. If you choose to take AP Chem, and you should, yep, any of the colored sheets I give you, you can always use. Lily, can you give one to Mallory, please? So if you take AP Chem, there are a couple of these on here that you have to memorize. My students tell me that they usually memorize them in general chemistry, not because I make you, but because you use it so much. So you just come to know things because of repetition. Okay, so let's take a look at what this is. When you have more than 2 capital letters in your compound, what you have is a metal plus one of these things. The pink sheet is full of what we call polyatomic ions. Now, if you understand what word bits mean, this name makes sense. Poly is a prefix that means many. Atomic means atoms or elements, right? What is an ion? Elliot? Something with a charge. I'm just going to call it a charge thing. So let's look at what is on this pink sheet. There are all these lovely names, but what I want you to look at is the column right here where it says formula. Notice how some of them are quite complicated, like the first one. And there's a lot going on there, but they all have a minus after them. So the polyatomic ions are almost exclusively negative ions. Yes, sir.
What did you say, charge?
Thing. So let me say this again. The polyatomics are almost exclusively negatively charged. There is one friendly exception, and he is over on the right side of your paper. It's called ammonia. And that can really throw us for a loop. So we'll get to some ammonium compounds, in a minute. All right, so how would you know that you need to use your pink sheet? Well, if you're looking on your green sheet and you decide, well, my first item is a metal, and I'm going to now count and my first metal is in group 1A, let's say, and now I've counted the number of capital letters in my compound, and it's more than 2. That means that I need to use the rule set number 3. Rule set number 3 says to name my polyatomic ion from the pink sheet. All right, so let me give you some examples of what this would look like. This is type 3. Okay, so let's look at what the rules say. The rules say to name the metal, and that's the first word. So Na is the element sodium. And then the only other thing that I have to do if I have a type 3 compound is to name the polyatomic ion from the pink sheet. So now I'm just gonna look at my pink sheet and try to find OH. OH is about halfway down, a little bit earlier than halfway down. Do you see it?
Yeah.
It's called hydroxide. And that's it.
So for the next one, we have to work with that.
Say that again, Donovan?
Are we gonna have to do anything?
Nope. Nope, because the rules don't tell us to. So let's look at MgSO4. What is Mg? Magnesium. And now, because I know that I have more than 2 capital letters, I have to find SO4 on my pink sheet. So I'm going to look, and it's almost like 2/3 of the way down. Do you see it? Okay, it is from the bottom, 1, 2, 3, 4, 5, 6, 7. SO4 is called sulfate. But wait, there are a bunch of things that look really similar to SO4. 2 lines down from sulfate is the word sulfite, which is SO3 2-. You have to be extremely careful. Gentlemen, it's just a known thing that boys of your age, men of your age, tend to be what is called impetuous. Has anybody told you that you're an impetuous person before? Any coaches told you that? Okay, so the word impetuous means that you make a snap judgment and that's what you go with before you collect all of the data that there is to collect. That's not a bad thing. Somebody who is impetuous is essential to be like an emergency room doctor. If you can't make a quick decision, like real quick, without somebody telling you what to do, you probably aren't going to be good at that job. In this though, you want to just make sure that you have, like you're fully concentrating on this because it is so easy to make mistakes. I cannot recommend enough having your work checked because I even make mistakes just like trying to write things down quickly. Sometimes you don't look through everything correctly. I'm not saying that you shouldn't do this while you're watching like Netflix or scrolling through stuff on your phone. You can, but you have to be a little careful. All right, so try to find PO4 on your pink sheet. It is it's a little bit higher than sulfate. Oh, geez, Billy Bruce. I don't know how that happened. It is phosphate. Say that again, Dominic?
How's it negative?
It has to be on the left side. So when you're looking for the name in your compounds, I gave you the list of common acids here. You're not going to use that at all on this assignment. So this is useful for you, but not until later. So don't pretend that this is not here. Elliot? It does define the proper name on here, but it doesn't, we're not going to indicate it in there. So, for example, like the number 4 here matters in that we chose sulfate and not sulfite. But does the charge matter? Is that what you're asking? Oh, no, it does not. Thank you, I'm sorry, I misunderstood. Yeah, so the fact that there are 3 of these lithiums here, do your rules say anything about making a prefix? No, then don't do it. Only use that prefix when it tells you to do so. I think that that's probably the most common mistake that people make is they want to put those prefixes because that's the first thing that I teach you. But really, if you just follow the rules, you'll never get it wrong. But you have to have the discipline to follow the rules. And then this last compound here is aluminum. And then that last thing is called acetate. Is that how I have it written on? Because that's how I write the acetate. So you could write it. This is the same thing as this, but this means nothing to me in my mind, so I always write it like this. Does that matter to you? No, but that's how I always write it, so that's how you'll always write it too. Yes, Dominic?
Why on the phosphate it's Li3PO4, but phosphate on here is PO4
3 minus. Yes, okay, so then that's another question. Why do you see this on your pink sheet, but this on your homework? We will talk about that when we talk about writing compounds formulas from the name. So you don't need to know why this has a 3 minus charge or why it's different yet, because I will give you the compounds formula. This will become important next week when I teach you how to go from the name to the formula. We will spend an entire day on just this. So don't worry about that for now. All right. What we're gonna do now is take a nice little brain break. So let's take a break until 18. So a nice solid 6-minute brain break.